Hi everyone, welcome to Unit 6 for PSTAT 5A. In this unit, we're looking at inference on mu, the population mean, and we're going to go through two types of inference. So for this first example here, we're looking at the confidence interval. So let's work through this. We'll highlight some special things to point out and then work through a confidence interval example. In this problem here, we are talking about the weights of 10-year-olds. So now we're given that these weights, so here body weights, they follow a normal distribution with standard deviation 8.5 pounds. Now, what you'll recognize is, again, the distribution is given to you, and usually in the past, we've been given the two parameters, the mean and the standard deviation. This time the mean is left out. And ultimately, that's the point of this problem. The point is we're going to estimate the mean body weight. Right, so that means our parameter of interest is mu, and we're trying to estimate what that is. Okay, so we're going to use our sampling distribution. So the next part reads, we have a random sample of 24 10-year-olds, and they have a mean weight of 62. So the question here is, well, how good is that as a sample, and can I use that to estimate? So let's look at these confidence interval rules here. So for Unit 6, the confidence interval for mu, you have two variations you can use. One of them requires the z distribution, or the other one requires the t distribution that you were introduced to in lecture. And the difference here to find out which one I'm supposed to use is the one with the z is if sigma is known. And the only reason it's known is if the problem gives it to you. Outside of that, if sigma is unknown, then we're going to use the t distribution, which estimates an additional parameter s that you see there, which represents the sample standard deviation. So when I go through and read the example, I notice this part here I underlined earlier, that I have a normal distribution with standard deviation 8.5. Now, because this 8.5 here did not come from the sample of my 10-year-olds, this is actually describing the entire population. So I know sigma is 8.5. So that means between my two rules for estimating mu, I'm going to use the one that has the z distribution. Once we're here, it's a matter of just plugging all the values in. So x bar, what is that? That's the sample mean. So after you take a sample, you're going to record an average, and that's given to us as 62. Right? The n is the sample size. We know we have 24 10-year-olds. And the sigma was given to us, we identified as 8.5. So now the only thing left I need is this z value. So where does this come from? This is going to come from our table. If you go through the lecture slides, you'll see that we have various tables you can use. And for this one, you can actually use the t table because as you learn, the t distribution converges towards the z distribution. So using the table, you guys should check along with me that for 95% confidence, the value of z is 1.96. All right, so again, we'll check that from the table. Once you have all four, now I can just substitute it into my confidence interval formula. So x bar again is 62. I've got this plus or minus the z-score, my known sigma, and the sample size. Another thing I'll highlight right now too is this part to the right of your plus or minus. Well, that is your margin of error. Since we're working with samples and obtaining our inference from samples, then samples are sensitive to the data you have. So there's always going to be a little bit of an error associated with it. And sometimes it's helpful just to work through what that is. So if I calculate this, here's my point estimate 62. I go through this product over here and I get 3.4. So what that means is from my sample at a 95% confidence level, I'm potentially off by 3.4 pounds. All right, so think of this as a little bit of wiggle room. So finally, putting these values all together, 62 plus or minus 3.4 gives me a window that is from 58.6 pounds all the way to 65.4 pounds. So at the end of the day, what I'm saying is I'm 95% sure that this interval from 58.6 pounds to 65.4 pounds will actually contain the true mean body weight of 10-year-olds.